today we're going to be looking at lesson 1.5, which is the inverse function. Before we do that, let's take a look at some of the warm-ups. So these are some of your homework questions from the previous night's homework. Page 35, let's take a look at 9a. So for 9a, ladies and gentlemen, they give you a function which is f at x equals negative 3x plus 8. Hopefully looking at that function, you realize that it's a linear function, and because it's got the slope and the y-intercept, you know there's going to be no restrictions either left, right, or up, down. So your domain is that x belongs to a set of real numbers, and your range is such that y belongs to a set of real numbers. Looking at b, this expression, guys, is a quadratic because you have the x squared, and hopefully you recognize that it's in vertex form. So from that expression, we automatically know, guys, that our vertex is negative 3 and 4. Okay, so that tells us where our maximum value is. The reason we know it's a maximum is because a itself is negative 0.5. The negative tells us it opens down. Okay, so for all quadratics, the domain is such that x belongs to a set of real numbers, and you have to look at your restriction on the maximum value for, or min or max value for the range. So the range is y belongs to a set of real numbers such that y is less than or equal to 4. If you drew a graph of this, ladies and gentlemen, you know your vertex is at negative 3 and 4. You know it opens down. So it tells you that you can go all the way down for your range, but for your going up on your range, you have to stop at your limit of 4. Okay? Question C, that's a square root function, ladies and gentlemen. Again, to remember that you can't have a negative under the square root, so you let the value under the square root be greater than or equal to 0, and then you solve for that expression. Okay, so all you need to say is that x is going to be greater than or equal to 1. So that's your restriction for the domain, and the range for all quadratic functions until we do transformations is y is greater than or equal to 0. And again, we're going to be focusing on the square root function when we take a look at our parent functions in a couple of classes. Okay, example D. P at x. Again, looking at the expression, guys, you know it's quadratic. In this case, we know the vertex is 2 and negative 5. Looking at our a value, you know a is positive, so that means it opens up. So in this case, we have a minimum. So when we do our restrictions, domain is such that x belongs to a set of real numbers. But for y, in this case, it can be greater than or equal to negative 5. Again, that's your optimal value there, and it's a minimum this time, so it has to be greater than or equal to negative 5. Question E. Again, looking at this expression, ladies and gentlemen, hopefully you realize there's no exponent, so it's a linear function. Although it's in the form y equals b plus mx, it's not y equals mx plus b, you still note that since there's a slope and a y-intercept, we know that x belongs to a set of real numbers and y belongs to a set of real numbers. Example F. Taking over this one, I would like everybody to make good note of this, and if you haven't done this one, let's do this one together because it has a little trick to it. Okay? Taking a look at this, ladies and gentlemen, we have r at x, and we have a square root of 5 minus x. Again, it's a square root function, and we allow the expression underneath the square root cannot be negative, so we let it equal greater than or equal to 0. The situation here, folks, and what makes this tricky is that you have a negative x. In most cases, it's x minus a number, but in this case, it's a number minus x. So this is what makes this tricky. So please star this and go over this together, guys. The trick with inequalities, i.e. when we've got a greater than or equal to sign, when you move the 5 over to the negative 5, that's fine. The sign stays the same. However, when you take a look at the dividing by negative 1, as soon as you divide by a negative expression, ladies and gentlemen, you have to note that you have to flip the inequality sign. So then instead of being greater than or equal to 1, it becomes negative. Or, sorry, it becomes less than or equal to 5. Let me pause for a second. Okay, guys, sorry for that pause. Let's just go over that again, guys. Whenever you have an inequality and you're solving for a variable, if the variable has to be divided by a negative value, you need to flip or switch the inequality sign. So that's the trick when you take a look at that. If you think about it, ladies and gentlemen, when you make sense, if that's going to be equal to 0, you know it's got to be 5x, right? Okay, so x has to be replaced with 5. All right, let's take a look at 16 here, folks. 16a, you could have an example where it can be on either side, ladies and gentlemen, as long as you know that your expression has to be onto or less than. Okay? And for 16b, again, when you take a look at your restriction on y, it has to be, on x, it has to be greater than or equal to -4. So you could have either just a straight square root sign, or you could just make it on both sides so you have the plus and minus value of that. As long as you draw only one function where it can be anywhere from -4 greater. Okay, so that is the review warm-ups. Now let's get into our lesson today, folks, and it's the inverse of a function, okay? So the inverse of a function is the reverse of the original. So key factor here, guys, is to remember that you're going to do reverse operations in reverse order. Quite often on my unit test, folks, people remember the reverse operations, but they will forget that it's in reverse order. So please make note of that. Okay? We could graph the cost of bulk candy as a function of mass. The inverse would be the mass as a function of the cost. This means that the point xy gets switched and becomes yx. Okay? So if you're graphing data points, ladies and gentlemen, on a graph and you're asked to find the inverse, for example, here's my smiley face at A and it's at 0.41. Flip x and y or switch x and y, it becomes 1, 4. Same with B. If you have 1, -1, you take the inverse of it and it becomes -1, 1. So again, ladies and gentlemen, when you do the inverse, you need to take a look at each data point. Take a look at C. That's 5, -5. When you take the inverse of it, it's going to become -5 and 5. The thing to remember, ladies and gentlemen, is we get what's called a mirror image of y equals x when dealing with data points. Okay? Now we can do the same thing when we have an expression. So looking at this expression, it's quadratic. We know there's a vertex, so the vertex is 0 and -3. So we plot 0, -3. We do our step pattern, over 1 up 1, over 1 up 3, over 1 up 5 on both sides. Okay, to get our original parabola. And then to do the inverse, we have to switch x and y. So when we do this, the vertex should actually become -3 and 0. Okay? And then from that, we switch when we go up instead of going over. So we go up 1, over 1, up 1, over 3, and up 1, over 5. Again, the mirror image through the y equals x. Taking a look at the next question, when you're given an equation, there are two methods to determine the inverse. The first method is by doing the reverse operations in the reverse order. I'll pause for a second. Okay, sorry for that pause, folks. So taking a look at this expression, guys, in the original form it is, we got f at x equals 2 times x minus 3 squared plus 1. Start with x, and what's happening with x? So in here you start with x and you say, hey, what happens to x? We subtract 3. Then you take that expression and then you square it. And then you multiply that by 2 and then you add 1. Now what we're going to do, guys, is the reverse. Again, start with x and do the opposite operation. So instead of adding 1, you're now going to subtract 1. Instead of multiplying 2, you're going to divide by 2. Instead of squaring, you're going to take the square root. Okay? And when you remember to take the square root, don't forget to take the plus or minus. Okay? And then instead of subtracting 3, you add 3. And then you get what's called the inverse. So this is the inverse of x equals plus or minus square root of x minus 2 divided, or x minus 1 divided by 2 plus 3. try it again, guys. Take a look at this linear function. What are we doing? We're starting with x. Currently, we multiply it by -3/5, and then we add 1. Again, to do the inverse, reverse the order and start with x. So x, subtract 3, and divide by -3/5. Keep that number the same. It's just the opposite operation. We're not flipping the fraction here. Okay? So again, when you get your inverse, in this case, ladies and gentlemen, you've got x minus 3 divided by -3/5. Again, please don't get caught up when you're dividing a fraction by a fraction. Again, you invert and multiply it, or use your calculator to get the expression simplified. So you should end up with -5/3x plus 5. Again, there's two ways you can get to that. Okay? Now, the other method that and this is the one I prefer, guys, is interchanging the variables and solving for y. So, first of all, we replace the function notation with y equals, and then wherever you see an x, it becomes a y, and wherever you see a y, it becomes an x. And then what we need to do, ladies and gentlemen, is rearrange and solve for y. That's what we need to do, solve for y. So first of all, -2y is negative here, so we're going to bring it over. It becomes positive. Bring the positive x over, it becomes negative. And to get y by itself, you divide every term by 2. So in this case, y equals -x divided by 2 plus 5/2. Don't forget, ladies and gentlemen, that it's really not y. We need to show that expression as the inverse because we have switched the variables. So then your final statement should be, therefore, the inverse of the inverse function is -x divided by 2 plus 5/2x, or 5/2. Okay? Try that example again, ladies and gentlemen, switching the x and y. So first of all, we rewrite it from function notation into y equals. We switch the x and the y, ladies and gentlemen, and then we want to solve for y. So to get y by itself, currently it's being divided by 3, so you've got to do the opposite, which is times by 3. Whatever you do to one side, you've got to do the same to the other. Once you've got rid of the denominator there, folks, then it's simply a matter of switching sides, and you get y equals 3x minus 5. But remember, folks, that's really not y, that's the inverse. So the inverse function is 3x minus 5. Here ends today's lesson. Please give a try with the homework, page 46, numbers 3, 5, 6, 8, 12, and give a challenger for 16. Have a great day and come see me for help.